So in this next section, we're going to start talking about polygons. Last time we talked about the basics of geometry, like points, lines, angles, planes. And so those things like lines and points and that, they start to make up shapes. So we're going to be starting to talk about polygons. And we're going to talk today about like finding perimeter, finding area of some of these basic shapes. So remember that a polygon is a plane. It's considered to be one of those geometric shapes. It's flat, it's a closed figure, so it's got lines that go all around it to create the shape. And then there's different types of polygons. Now a big family of polygons is called the quadrilaterals. So a quadrilateral is any shape that has four sides to it. Now there's a lot of types of quadrilaterals, and so we're going to kind of talk about what they are and what makes them different from each other, because there's slight differences between all the shapes, and that's what makes them what they are. So the first one is a quadrilateral with opposite sides that are parallel. So that would be a parallelogram. A parallelogram basically looks like a rectangle, but it's slanted. So you've got sides that are parallel to each other, but they don't have to be straight. Now if they are, so if you have parallel sides, but you also have right angles involved, that's how we get rectangles. So rectangles are a type of parallelogram, but it has all right angles. Now if you have a parallelogram that has all right angles and all equal sides, so it has to have both of those things, so that keyword there is and. That's how we get a square. So those four are kind of like the really basic shapes, and then we do have a couple other quadrilaterals and then other shapes out there that you'll see a lot of. So a parallelogram that has all sides that are equal length would be called a rhombus. So a rhombus is, or it's also known as like a diamond shape. A rhombus is like a square that all the sides are the same, but it doesn't have right angles. So it's like a parallelogram because it's kind of like slanted or tilted to its side. If you have a quadrilateral that only has two parallel sides, so not all of them are parallel or opposite sides are parallel, that's called a trapezoid. And then the last kind of basic shape that you've heard of before that has three sides is called a triangle. Now there's other shapes out there too, like pentagons, hexagons, heptagons, octagons, all of those things. But we're going to focus mainly on the different types of quadrilaterals and triangles, and then eventually we'll also talk about circles. But we're going to kind of just stick to these main shapes. So underneath that there in your guys' packet, you should see the different shapes that we just outlined there, and kind of just a plain example of what they each look like. Now they don't all have to look exactly like this. They can change a little bit. Not all triangles look like that one. You might have a right triangle, which means that there's a right angle inside of it. But that's kind of like the basic idea. Now we also have basic formulas for you guys to know, and this would be perimeter. Now perimeter is the distance around a shape. So if I wanted to know like how much I needed to create like a square or a rectangle, like fencing or something like that outside, I would need to know the perimeter of the area that I'm trying to cover. So in order to find perimeter, figure out what shape you're working with to understand what formula you want to use. Substitute what you know from the problem, like what they give you, what your dimensions are, into your formula, and then evaluate it. So this chart that I have in your guys' packet has all of the perimeter formulas for those basic shapes: parallelograms, rectangles, squares, trapezoids, so on. Now in the middle of this chart is all of the equations. There's a lot of letters. B's and S's and H's and L's and those kind of things. So over on the right side, I kind of put like a legend for you so that you know what S stands for. What does B stand for? Because some shapes have certain letters that other shapes don't. So it just depends on what you're working with. Like a square only has S, where like a rectangle has L and W. So just so you guys know what those letters stand for, that's all listed over here on the far right side. Okay, so let's do some examples with finding perimeter. All right, so for this first one, it says that the rear window of a pickup truck is a trapezoid whose shorter base is 40 inches, the longer base is 48 inches, and the non-parallel sides are each 16 inches. So how many inches of rubber gasket are needed to surround the window? You don't have to draw a picture, but if it helps you kind of figure out what's happening here, you can. So if you think about a trapezoid, basic shape looks like that. Now they're saying that the bases would be the parallel sides. So like the top and the bottom of the trapezoid. So the one on top would be 40, the one on the bottom would be 48. The non-parallel sides, so those would be the two kind of slanted, because they're going to eventually, if those lines kept going, cross, and that's what makes them not parallel. Those are each 16. Okay, so to find perimeter, we would just add those numbers up. 40 plus 16 plus 48 plus 16. And what did you get? 120. What would you guys label it with? Inches. It's going to be important that you guys are labeling your answers. Don't forget your label. I will take points off for that on like a test. You have to label because there's a difference between perimeter and area, and we'll even get into volume. So make sure that you're labeling appropriately. Okay, this next one, we've got triangular gables of an apartment unit under construction or outlined in contrasting trim. If each gable is 32 feet wide and 18 feet on each side, how many feet of contrasting wood trim are needed for each gable? And they tell us to disregard if there's any overlap. So you guys take a minute, figure out what the perimeter of this shape would be. So since they tell you that it's triangular, you're dealing with a triangle shape here. It says it's 32 feet wide, so that's probably the base of the triangle. And then 18 feet on each side. So what'd you guys find for the perimeter? Who's got it? 68, what's your label? Feet. All right, so when you know those basic shapes, rectangles, triangles, squares, that kind of stuff, they can start throwing what's called composite shapes at you. Composite shapes are when they start taking those little shapes and sticking them and creating a new kind of more complex shape. So that's what we're going to work with here. And on this one, we want to figure out what the missing dimensions are for this foundation. So I'm looking for X and I'm looking for Y. And then they also do say find the perimeter. So after we find X and Y, we'll also need to figure out what the perimeter is. So this is kind of like a three-part question. Now, what I would recommend you guys do when you're dealing with a composite shape is break it into smaller shapes that you can work with a little bit more easily. So this line that goes down by the X, I would almost just extend that and create two rectangles here. So for X is wanting to know how long just this piece is. How'd you find that? Not divided by. Subtract. So for X, we know that the far left side is 8 feet 6 inches. That whole side. Now the kind of where I wrote my like red dotted line, you know that that's 3 feet 6 inches from the right side of the figure, right? Because if this is a rectangle, these sides should be the same length. So what I can do is actually subtract. I can take 8 feet 6 inches and subtract 3 feet 6 inches. What's that going to leave me with? Just 5 feet. Okay, so x equals 5 feet. How would you do something similar but for y? Good. Take 12 feet 6 inches and subtract 5 feet 6 inches, because thinking about like the length of the bottom minus this length up here, because again, if I split my shape like this instead, this is 5 feet 6 inches here. So what's that going to give me? 7 feet. So y is going to be 7 feet. So now what I need to do is find the perimeter. So I need to add all of these sides together. Now, if it's helpful, you've got a couple measurements that have 6 inches. Like, let me erase some of my markings here. This has 6 inches and this has 6 inches. So if you wanted to, maybe combine those to get a foot. And then this has 6 inches and this one has 6 inches. So again, you can combine those to get another additional foot. That might make the math a little bit easier instead of having to add up all those inches. So what we could do is like 8 feet plus the 5 feet plus 1, because that's the 6 inches plus the 6 inches. You guys follow where I got the 1 from? And then I could do x and y, so 5 and 7. And then the last two I could do 3 and 12. And then add on an extra 1, because the 6 inches would be another 1 foot. Okay, so if we do that, what's this going to give us? $42. Someone check that and make sure I'm right. 42 feet. Okay, we feel okay about perimeter? Because we're going to go on to area now. So area is a little bit different because you're not only figuring out like how much space is around the shape, but also what it would take to cover the whole shape or to fill that shape in. So I've got another chart here for you guys with your area formulas that you'll need for all those shapes. And the process is the same as perimeter. Figure out what shape you're working with, figure out what formula would be the best, plug in what you know, and then evaluate it. And then just like the last chart, I've got your shapes listed on the left, the formula is in the middle, and then the kind of legend for those letters, like what does B stand for, what does H stand for, and all that. Alright, so I want you guys to take a couple minutes and do both 1 and 2 here. Read the problems, figure out what formula you need to use, and then actually evaluate it. So I'll give you a couple minutes to do that. Okay, first one's a trapezoid, so you should have used 1/2 times the height times base 1 plus base 2. So 1/2, the height they say is 4. The bases are 9 and 13. What did you guys get for a number here? Close. 44. How do we label area? Good. Centimeters squared. So whatever your unit is, you then have to put squared because you're talking about length and width. So it's two separate dimensions there. For a triangle, the equation that we want to use is 1/2 times the base times the height. The base for this one is 8. The height is 6. So what did you guys get for the area here? Good, 24, and then label would be inches squared. Okay, on this next one, we're going back to a composite figure here. Now be careful on this one because it says find the number of square yards of carpet that would be needed for this room, but what are the measurements that they give us on the picture in feet? So we're going to find the area in feet and then we're going to convert it to yards, and I'll show you how to do that. Alright, so what I would do is, again, kind of split this apart into two smaller shapes that we can work with a little bit easier. So I'm going to draw a line right here. I'm going to call this shape A and this shape B. That way I can just kind of refer to them and not have to say like the rectangle on the left, the rectangle on the right. Okay, so for A, it's a rectangle. It's got 9 feet by 7 feet. So I'm going to take 9 times 7, which is 63, and that would be feet squared. What would I do for shape B? 15 times 15, it's technically a square. So I would do 15 squared, or 15 times 15, which is 225 feet squared. So how would I find the whole area? Add. So 63 plus 225, what's that going to equal? Alright, so our area is 288 feet squared. Now we have to think about this in yards though, because we have to go to square yards. So remember, how many feet are in 1 yard? 3. Now we're talking about area, so it's a little bit different than just 1 yard being 3 feet. We're talking about a dimension squared. So what would be 3 squared? Squared. Not times 2. 9. Okay, so in 1 yard squared, there's 9 feet squared. So it's a little bit different. It's not 1 yard and 3 feet because we're talking about something that's two-dimensional here. So when I go to convert this, I'm going to take 288 feet squared, and I'm actually going to divide by 9 feet squared because that's going to get me my yards. So 32, and that would be yards squared. So when you're converting between measurements on area, think about your original conversion factor. So like if it was feet to inches, let's say, I would have 12 inches for 1 foot. But if I'm talking about something squared, I would then have to use 144 because 12 squared would be 144. So it's a little bit different. You won't run across that a ton, but it happens sometimes. So just make sure that you square your measurement before you try to convert it. And yeah, and then that would get you 96. Okay, last one here. We want to find the area of this gable end. We've got these dimensions. Now, something that didn't get thrown into this picture that I think you're going to want to know. If they cut this bottom, because we're going to eventually kind of think about this line being drawn here to create a triangle and a trapezoid. I need to figure out like what the dimension of the base of that triangle is. So what they neglected to put in here is that these measurements are going to be the same. They're both going to be 3 feet, which means that this middle piece is going to be 23 feet. That's helpful because we need that 23 feet for the triangle on the top, because the base of the triangle is not the same as the base of that bottom trapezoid. And we also need it for the top of the trapezoid. So what I did is when I drew in the lines there, I created 2 triangles that are equal on either side of kind of that rectangle shape in the middle. So I know that they probably have to be about the same amount. So what I did is I just thought, how could I cut 29 so that it would be even on both sides, but it wouldn't be longer than, like a reasonable amount. So that's how I got the 3 feet and the 3 feet there. All right, so for my triangle on top, I'm going to use 1/2 times base times height. So I'm going to do 1/2. The base of that triangle is that 23 feet. And the height is going to be 5 feet 4 inches. How could we write that in just feet, though? How could I write 4 inches as like a fraction of a foot? Think about how many inches are in a foot. 12. So what would be 4 over 12? 1/3. So 0.33 like you said. So in case you didn't understand where that came from, you're taking 4 over 12, reducing it, which is 1/3. So 5.3 repeating, or if you want to keep it 5 1/3, you can. Okay, and so this is going to come out to be what? Point what? Okay, so I'm just going to round it to 0.3 feet squared. Now let's do the trapezoid. So we're going to do 1/2. The height is 8. And the 2 bases are the 23 and the 29. What does that equal? That's like my final answer. What's just the area of the trapezoid? Okay, so 208 feet squared. So then to finish, we're going to add the 2 dimensions together. 61.3 plus 208, and that's how we get 269.3, and this would be feet squared. Like I said, this would be for the total.